This is the place where ships and planes disappear, the Bermuda Triangle. Located in the Sargasso Sea, the Bermuda Triangle is formed by Bermuda Islands, Miami, and San Juan.
On December 5, 1945, 5 United States Navy torpedo bombers, Flight 19, took off from Fort Lauderdale, Florida, for a routine training exercise over the Atlantic Ocean. The weather was clear. The pilots were experienced. The flight plan was simple. Fly east, turn north, turn west, fly home. 2 hours and 15 minutes. They had done it dozens of times. They never came back. At 3:45 p.m., roughly 90 minutes into the flight, Taylor radioed the Fort Lauderdale tower. "Both my compasses are out. I'm trying to find Fort Lauderdale." The tower told him to fly west, toward the sun, which was setting. Taylor responded, "We don't know which way is west. Everything is wrong. Strange. We can't be sure of any direction. Even the ocean doesn't look as it should." The tower operators could hear panic in the voices of the other pilots in the background. They tried to get a radar fix, but the planes were too far out, and the signal kept breaking up. At 4:25 p.m., Taylor transferred command to Captain Edward Powers. The tower heard fragments. "When the first man gets down to 10 gallons of gas, we will all land in the water together." They were planning to ditch in the open Atlantic. At 6:20 p.m., a faint transmission was received. "FT, FT," the flight's call sign. Then silence. At 7:04 p.m., the last signal, too weak to decode, faded from the frequency. A PBM-5 Mariner flying boat, a 77-foot search and rescue aircraft with a crew of 13, was dispatched from Banana River Naval Air Station at 7:27 p.m. to search for Flight 19. The Mariner reported routine departure and climbed to cruising altitude. At 7:50 p.m., a merchant ship in the area reported seeing a ball of fire and an explosion in the sky. The Mariner was never heard from again. No wreckage, no oil slick, no debris. 6 aircraft, 27 men, gone. The Navy investigation lasted months. The final report stated, "We are not able to even make a good guess as to what happened." The original findings attributed the loss to Taylor's confusion and disorientation. Taylor's mother protested. The Navy amended the report to read, "Causes or reasons unknown." It is the only time in U.S. Navy history that an official investigation concluded with those words. That was the event that gave the Bermuda Triangle its name and its legend. In the 80 years since, over 75 aircraft and ships have reportedly disappeared in the roughly 500,000 square mile area of the Atlantic Ocean, bounded by Miami, Bermuda, and Puerto Rico. Some vanished in clear weather, with experienced crews, and no distress calls. Some vanished mid-sentence during routine radio communication. Some were found days later, drifting, with no crew aboard, no signs of struggle, no damage, food still warm on the table. The cases are haunting in their specificity. The USS Cyclops, March 1918, a 542-foot Navy cargo ship carrying 309 crew and passengers and 10,800 tons of manganese ore. Disappeared without a distress call somewhere between Barbados and Baltimore. The largest non-combat loss of life in U.S. Navy history. No wreckage found, no explanation ever established. The Navy searched for months. Nothing. 309 people vanished from a ship longer than a football field. The Star Tiger, January 1948. A British South American Airways Tudor 4 aircraft carrying 31 passengers and crew from the Azores to Bermuda. The pilot reported normal conditions and confirmed his position as 400 miles northeast of Bermuda. That was the last transmission. The plane was never found. No wreckage, no oil slick, no emergency signal. The Star Ariel, January 1949. The Star Tiger's sister aircraft. Same airline, same aircraft type, same route region. Disappeared between Bermuda and Kingston, Jamaica, 1 year after the Tiger. 20 passengers and crew, never found. After losing 2 identical aircraft on similar routes within 12 months, British South American Airways was absorbed into Boac Sec, the Marine Sulphur Queen, February 1963, a 524-foot tanker carrying 15,260 tons of molten sulfur and 39 crew members, disappeared in the Florida Straits. No distress call. The Coast Guard found life preservers and debris, but no bodies. A 524-foot vessel disintegrated without sending a single radio message. The Witchcraft, December 1967. A 23-foot cabin cruiser that called the Coast Guard reporting a minor problem, a damaged propeller, while anchored 1 mile off the Miami shore. The Coast Guard arrived 19 minutes later. The boat was gone. No wreckage, no debris, 1 mile from shore, in 19 minutes. The explanations have ranged from the scientific to the absurd. Rogue waves, magnetic anomalies, methane eruptions, alien abduction, portals to other dimensions, the lost technology of Atlantis. The U.S. Coast Guard says there is nothing unusual about the area. Lloyd's of London does not charge higher insurance premiums for ships transiting the Triangle. Statistically, they say, the number of disappearances is proportional to the heavy traffic in the region. In 2026, an AI system processed every documented disappearance in the Bermuda Triangle since 1945. Coordinates, dates, weather conditions, ocean currents, magnetic field readings, seafloor topology, tidal patterns, and atmospheric data, and mapped them against every known physical phenomenon in the region. The pattern it found does not support the supernatural theories, but it does not support the nothing unusual claim either, because the disappearances are not random. They cluster, and they cluster in locations that should terrify anyone who sails over them. The AI began with a complete database of reported disappearances, drawn from U.S. Navy records, Coast Guard incident reports, National Transportation Safety Board investigations, Lloyd's of London casualty records, and maritime databases spanning 80 years. It excluded cases with confirmed explanations, mechanical failure, pilot error, storms, and focused on the cases classified as unexplained or insufficient evidence for determination. The resulting dataset contained 52 incidents involving aircraft and vessels that disappeared under conditions where no conventional explanation could be established. For each incident, the AI mapped the last known coordinates, the time of day, the sea state, the wind speed and direction, the air temperature, the water temperature, the barometric pressure, the magnetic declination at that location and time, and the depth and topology of the seafloor beneath the last known position. It also incorporated satellite-era data, sea surface temperature maps, ocean current velocity, gravitational field measurements, and atmospheric electromagnetic readings for the incidents that occurred after 1970. The first finding was immediate and unambiguous. The disappearances are not evenly distributed across the triangle. They cluster in 3 distinct zones. Zone 1, a corridor approximately 80 miles east of the Florida coast, running from Fort Lauderdale south to the Florida Keys, directly over the western edge of the Gulf Stream, where it accelerates through the Florida Straits. Zone 2, an area approximately 150 miles southeast of Bermuda, over the abyssal plain where the Atlantic reaches depths of over 19,000 feet, among the deepest waters in the Atlantic, outside of the Puerto Rico Trench. Zone 3, a zone approximately 100 miles north of Puerto Rico, directly over the edge of the Puerto Rico Trench, at 28,232 feet, the deepest point in the entire Atlantic Ocean and the 5th deepest point on Earth. 3 zones, not scattered randomly, not distributed proportionally to traffic, concentrated in 3 specific locations. The AI calculated the probability of this clustering occurring by chance, given the traffic distribution across the triangle, and found it to be statistically significant. The disappearances are disproportionately concentrated in these zones compared to what random chance would predict. The AI also found temporal clustering within each zone. Disappearances in Zone 1 tend to occur in clusters of 2 to 3 incidents within 18 months, followed by years of silence. Zone 3 shows a similar pattern but with longer intervals, clusters every 5 to 7 years. This intermittent behavior is inconsistent with a permanent hazard, like a reef or a current. It is consistent with an episodic phenomenon, something that activates occasionally, causes havoc, and then goes dormant. The AI cross-referenced the disappearance clusters with seismic data from the U.S. Geological Survey. Every cluster in Zone 1 correlates with a period of elevated seismic activity along the Caribbean-North American plate boundary within the preceding 6 months. Every cluster in Zone 3 correlates with seismic events along the Puerto Rico Trench. The correlation is not perfect. Seismic activity does not guarantee a disappearance, but every disappearance cluster follows a seismic event, every single one. Something about these 3 locations is different, and the AI found what it is. Beneath the seafloor of the Western Atlantic lies one of the largest deposits of methane hydrates on Earth. Methane hydrates, also called fire ice or clathrates, are crystalline structures formed when methane gas is trapped inside a cage of water molecules under the extreme pressure and cold temperatures found on the continental shelf. They look like ice. They burn when ignited, and they are unstable. When methane hydrates destabilize, triggered by seismic activity, changes in water temperature, or shifts in pressure, they can release enormous quantities of methane gas in sudden, explosive eruptions. A 2017 study from the Arctic University of Norway in Tromsø documented 800-meter-wide craters in the Barents Sea floor, massive depressions blasted into the seabed by methane hydrate eruptions, so powerful they left scars visible from orbit. The AI mapped the known methane hydrate deposits in the Bermuda Triangle region against the 3 disappearance zones. The correlation was striking. Zone 1, the Florida Straits Corridor, sits directly over the Blake Ridge, one of the largest documented methane hydrate deposits in the Atlantic. The U.S. Geological Survey has mapped this deposit extensively and confirmed that it contains billions of cubic meters of trapped methane. Zone 3, the Puerto Rico Trench area, sits at the boundary between the Caribbean and North American tectonic plates, one of the most seismically active zones in the Atlantic, where the subduction of one plate beneath another creates the pressure and temperature conditions that both form and destabilize hydrate deposits. The methane eruption theory, first proposed in the early 2000s, works like this. A massive underwater release of methane gas reduces the density of the water above it. Ships floating on water that suddenly becomes 20% to 40% less dense lose buoyancy instantaneously. They do not slowly sink. They drop, like an elevator with a cut cable. The ship falls into a column of aerated, frothy water that cannot support its weight, and sinks so fast that there is no time to send a distress signal, deploy life rafts, or even understand what is happening. The wreckage sinks to the abyssal depths, 19,000 to 28,000 feet, where it is impossible to find with conventional search technology. For aircraft, the mechanism is different but equally devastating. Methane rising through the water column enters the atmosphere as a concentrated gas cloud. If an aircraft flies into a methane cloud, 2 things happen. First, the methane displaces oxygen, starving the engines. Piston engines and jet turbines require oxygen to burn fuel. A sudden drop in atmospheric oxygen concentration causes engines to lose power or flame out. Second, methane is highly flammable. If the engine ingests methane and the concentration reaches the ignition threshold, the result is an explosion. No distress call, no wreckage, no survivors. Laboratory experiments at Monash University in Australia confirmed that methane bubbles can sink a scale model ship by reducing water density. The physics works. The geology supports it. The locations match. But there is a problem. The methane theory is elegant, scientifically grounded, and deeply satisfying. It explains the sudden disappearances. It explains the lack of wreckage. It explains the clustering in specific zones. It explains the compass anomalies. Methane eruptions produce electromagnetic disturbances that can interfere with navigation instruments. But in 2026, a joint research team from the University of Miami and the Woods Hole Oceanographic Institution published findings that threw the methane theory into doubt, while simultaneously raising a far more unsettling possibility. The team completed a high-resolution sonar mapping of the seafloor beneath the triangle's most historically active zones. If the methane theory were correct, they expected to find a landscape shaped by gas eruptions, craters, vents, pockmarks, and disturbed sediment. The same features documented in the Barents Sea by the Norwegian team. They did not find them. Instead, Large sections of the mapped area showed unusually smooth, glassy topology, as if sections of the ocean floor had been subjected to intense, focused heat events. The lead researcher, Dr. Maria Suarez, described the findings as unexpected, a diplomatic understatement that sent the oceanographic community into a quiet frenzy. The AI analyzed the sonar imagery and compared the seafloor topology to databases of known geological formations. The smooth, glassy sections are inconsistent with methane eruptions, which leave cratered, irregular surfaces. They are inconsistent with normal marine sedimentation, which produces layered, gradually varying topology. The closest match in the AI's database was the vitrified surfaces produced by extreme heat, the same kind of glassy texture found at nuclear test sites, at the Tal El Hammam cosmic airburst site, and at fulgurite formations created by lightning strikes on sand. The AI flagged this finding as anomalous. No established geological mechanism produces this topology in a deep marine environment. It did not speculate about causes. It reported the data. There is one more element that the AI incorporated, an element that predates the modern legend of the Bermuda Triangle by centuries, and that has been reported consistently by mariners since Christopher Columbus. Compass deviation. Compasses in the Bermuda Triangle do not always point north. They point to what is called magnetic north, the wandering magnetic pole, rather than true geographic north. In most parts of the world, the difference between magnetic north and true north, called magnetic declination, is small and predictable. It changes slowly over decades and is published on every nautical chart. In the Bermuda Triangle, the declination is unusually variable. It shifts unpredictably, sometimes dramatically, over short distances and short time periods. Columbus himself documented this phenomenon during his first voyage to the Americas in 1492. His log records that on September 17th, 3 days after leaving the Canary Islands, the compass needle shifted away from its expected declination. Columbus was alarmed enough to record it, but experienced enough to keep the observation from his crew, who were already terrified of sailing into unknown waters. 500 years later, modern navigators report the same thing. Sudden compass swings of 5 to 10 degrees that last minutes or hours, and then correct themselves without explanation. In 1970, pilot Bruce Gernon reported the most dramatic navigational anomaly in modern triangle history. Flying a Bonanza A-36 from Andros Island in the Bahamas to Palm Beach, Florida, Gernon described entering a tunnel-like formation in a cloud, a cylinder of swirling cloud with clear air inside, that surrounded his aircraft. Inside the tunnel, his compass spun continuously. His navigational instruments failed. His radio produced only static. When he emerged from the cloud, he was directly over Miami Beach, 100 miles from where his instruments said he should be, and the flight had taken 47 minutes instead of the expected 75. He had covered 250 miles in a time that would have required an airspeed 50% higher than his aircraft's maximum capability. Gernon called the phenomenon electronic fog. The AI could not evaluate his subjective experience, but it incorporated his coordinates, timing, and the meteorological data for that date. The location of Gernon's anomalous experience falls within Zone 1, the same zone where the highest concentration of disappearances occurs. The AI mapped the magnetic field data across the triangle using satellite magnetometer readings and historical naval observations. It found that the magnetic anomalies correlate strongly with the 3 disappearance zones, the same zones where the methane deposits are concentrated and where the anomalous seafloor topology was detected. The AI modeled 3 possible explanations for the magnetic anomalies. First, large iron deposits in the bedrock beneath the seafloor could distort the local magnetic field. The Puerto Rico Trench and the Blake Ridge both sit on geologically complex terrain with known mineral deposits. Second, the magnetic anomalies could be caused by the same methane eruptions that the methane theory proposes. Large-scale gas releases create electrical charges through a process called triboelectrification, generating electromagnetic fields strong enough to disrupt compasses. Third, the geological structure beneath the triangle may contain large formations of magnetite or other ferromagnetic minerals that create local magnetic dead zones. None of these explanations are supernatural. All are consistent with known physics, but the AI noted something that no previous analysis had quantified. The magnetic anomalies in the three disappearance zones are not constant. They fluctuate. They come and go. They are episodic, which means that most of the time, the triangle is perfectly safe. Compasses work, ships sail through without incident, planes fly overhead without problems. But occasionally, something activates. A methane eruption, a seismic event, an electromagnetic pulse from a geological source, and for a brief window, the conditions in a specific zone become deadly. The AI estimated that these activation events occur with a frequency of approximately once every 3 to 5 years in any given zone, brief enough that most traffic passes through without incident, frequent enough that, over 80 years, dozens of ships and aircraft have been caught in the wrong place at the wrong time. The AI's final output was a predictive model, a probability map of the Bermuda Triangle showing where and when the next disappearance is most likely to occur. The model is based on 3 layers. Layer 1, SeaFloor topology, specifically the locations of methane hydrate deposits and the anomalous glassy formations. Layer 2, seismic activity, since methane eruptions and electromagnetic anomalies are both triggered by seismic events along the tectonic boundaries. Layer 3, seasonal and climatic factors, water temperature, which affects hydrate stability, and storm patterns, which affect both sea state and air traffic routing. The model predicts that the highest risk windows occur during the months of August through December, the same months when Atlantic water temperatures peak, destabilizing the methane hydrates, and when hurricane season drives additional air and sea traffic through alternate routes that cross the active zones. The AI also found a temporal pattern in the historical data that no human analyst had detected. The disappearances are not evenly distributed over time. They cluster in multi-year waves, periods of 3 to 5 years, with multiple incidents, followed by periods of 5 to 10 years, with few or none. These waves correlate with cycles of seismic activity along the Caribbean-North American plate boundary. When seismic activity increases, disappearances increase. When seismic activity decreases, disappearances decrease. The correlation is not perfect. There is noise in the data, as there always is in small data sets, but it is statistically significant. The Bermuda Triangle is not a permanent death zone. It is an intermittent one, a geological system that occasionally, rarely, unpredictably, but repeatedly, produces conditions that can destroy a ship or an aircraft without warning and without leaving evidence. And the AI has for the first time mapped the mechanism, identified the zones, and predicted the windows. The Bermuda Triangle has been a legend for 80 years. It has been the subject of hundreds of books, dozens of documentaries, and thousands of conspiracy theories. It has been attributed to aliens, Atlantis, wormholes, time warps, and the wrath of Poseidon. The US government says nothing unusual happens there. The insurance industry agrees. Most scientists dismiss it as a statistical illusion, a myth created by selective reporting and sensational journalism. The AI does not dismiss it. The AI does not sensationalize it. The AI maps the data. Every coordinate of every disappearance, every date, every instrument reading, every sea state, every magnetic anomaly, every methane hydrate deposit, every seismic event along the Caribbean plate boundary, every anomalous sonar reading from the 2026 Woods Hole survey. And it says, the disappearances are not random. They cluster in 3 zones. The zones correlate with methane hydrate deposits, tectonic boundaries, magnetic anomalies, and anomalous seafloor topology. The clustering is statistically significant. The temporal pattern correlates with seismic cycles. The compass anomalies correlate with the disappearance zones, and the seafloor in the most active zones shows a smooth, vitrified texture that no established geological mechanism explains. The Bermuda Triangle is not supernatural, but it is not normal either. It is a region where the seafloor occasionally produces conditions, methane eruptions, electromagnetic pulses, buoyancy collapse, atmospheric gas clouds that are invisible, unpredictable, and lethal. Most of the time it is safe. Hundreds of ships and planes cross it every day without incident. But occasionally, rarely, in a window that lasts hours or maybe minutes, something activates. The water loses its density, the compasses lose their reference, the engines lose their oxygen, the radio loses its signal. And whatever is caught in that window, a 542-foot cargo ship, a squadron of torpedo bombers, a 23-foot cabin cruiser 1 mile from shore, vanishes, without a trace, without a signal, without an explanation. The Witchcraft was 1 mile from Miami when it called the Coast Guard. By the time they arrived 19 minutes later, the boat was gone. 1 mile, 19 minutes, in calm seas. That is not pilot error. That is not bad weather. That is something else. Flight 19 took off at 2:10 p.m. on December 5, 1945. The weather was clear. The compasses worked. The engines were fine. By 4 p.m., everything had changed. The compasses were spinning. The ocean did not look right. The flight leader did not know which way was west. By 7:04 p.m., the last radio signal faded. 5 planes, 14 men. The Navy said, causes or reasons unknown. The only time those words have ever appeared in an official U.S. Navy report. The AI knows the zones. The AI knows the cycles. The AI knows the windows. The question is not what the triangle is. The question is when it will activate again, and whether anyone will be listening. Subscribe, because the AI keeps finding patterns in places the world wrote off as myth. The Bermuda Triangle is not a legend, it is a system, and the system is still active. The next file is on your screen.